All right, so now that we know generally what an arc length is all about, let's talk about how we come up with the fraction or the portion of the circle that matters to us given an example. Here in number 1, we can see a diameter has been drawn, and I care about the fraction of the circle that's on the right-hand side here, and we know that this diameter will give us a 180-degree arc measure. So to determine what percentage or what the fraction of that circle is that I care about, I take that 180 degrees, the portion that matters, divide it by 360. It's kind of like what of the circle, what of the whole circle is in play here. When I do this in my calculator, it's just 180 divided by 360. Math, enter, enter. And every time I do that, which we've done many times, I know, it will give you the formal fraction. In this case, it's 1/2. Oops, my little number 1 went away there. All right, let's take a look at this next one. They've given us a 90-degree angle. And in this case, let's talk about this portion of the circle, what we don't know. Okay, given a 90-degree central angle, of course, we're going to have a 90-degree arc measure. But I care about the rest of the story. So I need to take the total circle, subtract 90 from it. I come up with 270 degrees. So the portion that I care about is going to be, or the fraction of the whole thing will be that arc measure divided by 360. And when you do that in your calculator, you'll come up with 3/4. That makes sense. You know, you can see that if you were to cut this into 4 equal pieces, this is 1/4 of it. The rest of it's 3/4. But just to make sure we all understand how we came up with it. Finally, I have this circle. I've got this piece that matters to me. They've given us a central angle of 150, so I know that the arc measure will be 150 as well. So the fraction of the circle that I care about, that I have highlighted, will be 150 divided by 360, or 150 of the whole thing, or of 360. So let's take a look at that in the calculator. I'm going to do 150 divided by 360, and straight to math, enter, enter. And I come up with a fraction of 5/12. Or wait a minute, what was that? 5/12, yeah, okay. So this is not as simple to determine. It is important to know that this is the process you would use to determine which portion of the circle matters to you. So let's talk about what the formal formula is for arc length of a circle. The length of the arc, remember, just the straight line distance, for lack of a better term, the distance a little bug might just crawl all the way from here to here. We call that, it's going to be equal to the arc measure, which I'm going to just show abbreviations if you prefer. Okay. Arc measure divided by 360 multiplied by the circumference, which we know to be C above. Go ahead and pause the video, make sure you have all that written down, and then come back. All right, so given the information above, we want to determine the arc length of each of those circles, and we're going to use the formula to do so. I'm going to write the formula again. And again, I've got arc divided by 360, arc measure divided by 360 times the circumference. Now keep in mind, our formula sheet, as we saw above, will give us the circumference as either 2 pi r or pi d. In my case here, I've been given the radius, so I could actually just rewrite this with the actual circumference formula, which is 2 pi r. So as we did in the beginning of the class, we're going to just straight up erase replace. In this case, everything we need on the right-hand side is given to us. So we can just put that information in. 180 divided by 360. Again, that was the fraction of the circle that we care about. And then we multiply it by the circumference. In this case, it would be by 5. It would be the radius that's important that I'm going to input. So let me go to the calculator, make sure we all see how this looks. This is multiplied. So we don't necessarily need, it's all multiplication. It's a very forgiving means, but just for giggles, let's go ahead and make it look just like what we wrote down. So 180 divided by 360 times 2. times, again, the pi is that second caret, brings up my pi, times 5. And when I do the math, you can see that this value with a decimal point, oops, is 15.7. So we'll just write 15.7, round it to the tenths place. This radius was measured in units of inches, and so now my arc length is also in units of inches. Let's take a quick step backwards though, and let's do this by using or finding it in what we like to call in terms of pi. We looked at that a bit above. So I'm going to take that same information, 180 divided by 360. Okay, I got that from over here. I'm going to multiply this by 2 and then by 5, but I'm going to not include the pi. Okay, when I not include the pi, I'm just going to show that figure I come up with here, the mathematical figure, and then just throw a pi right next to it. It feels and looks the same exact way. So multiply that by 2 times 5, again leaving the pi out this time, and look at how pretty that number is. Nice number at this point. It's straight 5. So to show this in terms of pi, we would simply say 5 pi inches. And that's legal. In fact, that's the way the SOL is going to want it to look in some cases. When I take that 5, again, all just the numbers dumped in there, and multiply it by pi, okay, again, caret, a second caret, I come back to what I came up with initially. So it's just a matter of you guys using whichever method you want. The answer choices they're going to give you, sometimes they're going to look like 5 pi. Sometimes they're going to look like 15.7. And the good thing is, it's just like with a radical situation. You have the means and the methods with your calculator to determine which one it is. You just have to put the information back in. All right, so given what we did on number 1, go ahead and try number 2, and number 3. Go ahead and pause the video and then check your work, and we'll go from there. All right, and you should have gotten that on number 2, 56.5 meters, or in terms of pi, it would be 18 pi. Again, multiply the 18 and the pi, and you'd come back to 56.5. And then for 3, 7.9. If you have any issues, or if you didn't get those answers, please raise your hand, and we'll give you